So let's finish up with some real-world testing issues and questions that we run across weekly where people are in the field doing relative humidity testing, very critical, and they have a lot of questions and comments, and again we hear many of them every week. So let's talk about one of the major obstacles or hurdles in construction these days, which causes, and some misperceptions by the way, that really cause some headaches in the field. Fast track construction. Well, that's a good thing, but the problem is people, owners, general contractors are often in a big hurry. They don't want to believe that the slab is not ready to put some kind of a floor covering or coating down. They want to move along, get the building open, and allow the owner to start generating revenue from whatever business is going to be in that building. The problem is, what's very misunderstood, but well documented scientifically, is that concrete does not dry that fast. For example, I've had calls from flooring contractors stating to me that they have a job, they need to get a floor covering or coating down, and almost my first question is, how long has that slab been down? I've heard some almost ridiculous answers to the tune of weeks, 6 weeks, 8 weeks, and they want to know if that slab is ready or the owner is pushing them to put something down. Just the drying rate of concrete, alone tells you that that slab is not ready. For example, a rule of thumb with concrete drying is approximately 30 days for each inch of thickness of that concrete slab. Just a rule of thumb. And that's under pretty optimum drying conditions. But often, very often, in fact probably most of the time, those drying conditions in that building are not optimum. The building has been open. It may have been open for months. They have only had the climate controls turned on in the last 2 or 3 weeks, and they want to go ahead and begin putting the floor covering or coating down. They're getting relative humidity readings with a very rapid and very accurate rapid RH method in the high 80s and 90s, and the reaction is from the owner or the general contractor often, or even the installer themselves, is that there's no way that this slab can be that wet. But the answer is yes, it can, because it takes a long time for a slab to dry and a lot longer when it doesn't have ideal conditions. And lightweight aggregate concrete, this concrete that's often used on second and third floors, not slabs on grade, lightweight aggregate concrete can take 2 to 3 times longer than regular aggregate concrete to dry. So it can take many months for that slab to dry out. If the surface is a hard troweled surface, it slows it down. If the water cement ratio was pretty high when that concrete went in, that will mean the concrete will take longer to dry. There are a number of factors here, and the relative humidity testing is just telling them what they should already know. So let's look at another field example that we get in question, and that is what levels of relative humidity are common, what levels of relative humidity are okay, levels of temperature, ambient conditions, and things of this nature. Well, first of all, the correct maximum relative humidity levels vary from product to product, from adhesive to adhesive, whether it's epoxy, a rubber floor, or what have you. And that can range, quite a range actually, anywhere from maybe 75% up into the mid-90s depending on what it is. Another example would be a lot of sheet goods, vinyl, composition tile, products such as this and the associated adhesives. 75% to 80% is a very common number, but the manufacturers set that guideline. Most of the major manufacturers of resilient flooring and in the wood side and some of the other sectors know what that value is. They've set those guidelines for relative humidity. And as we saw earlier in Howard's presentation, there is no correlation between relative humidity testing down in the slab and calcium chloride testing. That's why they have a separate spec for relative humidity. It's very important. And so it is a range. There are some moisture control or moisture mitigation products, topical products that go on a concrete slab that can stand very high relative humidities. But again, you need to rely on the manufacturer. It's incumbent upon the manufacturer to set those guidelines. Now, what about ambient conditions? They vary. We saw earlier in Howard's presentation that ambient conditions have, especially temperature, has very little effect on relative humidity readings down in the slab. It can have a huge impact on calcium chloride readings though. They are very affected by ambient conditions. And so those ambient conditions can range quite a bit. Now, concrete slab temperatures, typically normal temperatures will run in the mid-50s to the mid-60s. Sometimes they're a little higher, sometimes just a little bit lower, but that's a pretty common range for slab temperatures when we're measuring relative humidity. And again, talking about so-called safe relative humidity readings, those will vary depending on the product that you're going to use. So you need to refer to the manufacturer's guidelines when you're doing this. Let's just step back a minute and touch on another topic related to the fast-track construction situation. Often what I've seen is the general contractor or the owner not liking what they're seeing with accurate relative humidity readings with the Rapid RH, and we've already seen why it is very accurate and doing its job according to ASTM F2170. So what will happen is they will want to call in a third party to do so-called independent testing to try and determine do the readings square with other relative humidity testing that they want to have done. Again, let's go back to a problem that you can see with sleeve methods, with probes that may not be verified for calibration, with not going to the correct depth. What we have often seen, you may have readings with a Rapid RH in the mid-80s to 90 range. A third party will come in not knowing how to correctly do the sleeve and external probe method. They have not had their probes calibrated or verified for calibration. They may be contaminated, and often they are, and they're going to read downscale. They'll come in with very low readings, and I'll give you a good example of this. A slab that's only been down 2 months, has not had ideal drying conditions, and they may be getting readings in the mid-70s. It's not even possible. So without doing any relative humidity testing, you know that that concrete slab has to be in the high 80s to 90. Yet they're getting readings that are very, very dry and appear to be okay, but they're not okay because of, again, any number of reasons. Either the probes have been contaminated, they're reading downscale, the sleeves are not tight in the hole, we're getting contamination from ambient air, or just the sleeve design itself is flawed, so we're getting relative humidity readings from different gradients in the slab, and that is not correct, and we've seen that earlier. So sloppy testing methodology or non-calibrated probes can cause this problem. But with the Rapid RH, only reading at 40% of depth, having NIST traceable calibration for the Rapid RH smart sensors allows you to easily meet ASTM F2170 and not be concerned about possible underestimation of the relative humidity in a concrete slab.